All right, we'll look at some of the homework problems that are in section 7.2, where we have Hannah went to the store and bought a chair for $15.45, a rake for $11.11, a spade for $13.96, a mower for $135.09, and two six-packs of beer for $2.06 each. What was the bill? All right, this one is just a simple addition problem, which I've already set up at the bottom of this sheet here. And as you can see here, I've listed the cost for each of the items that Hannah bought, which was a chair for $15.45. The rake was $11.11. The spade was $13.96. The mower was $135.09. Then she bought two six-packs of water for $2.06 each. So I listed the $2.06 twice. So I'm just going to add these numbers up together. And as you can see, I've already done the addition and came up with $179.73, which is the cost of the bill. So here, Hannah's total bill was $179.73. So that's how you'll answer problem number one, just doing a simple addition. Number two, a U.S. $1 bill was valued at 7.8 Chinese yuan, which is Chinese currency, on a particular day. What was the value of $723.01 in Chinese yuan on that day? And we're going to round to the nearest hundredth as needed, which means we're going to round to two decimal places because we're dealing with money amount. All right, in this case here, I set this up as a multiplication problem. So if $1 represents 7.8 Chinese yuan, $723.01 represent how many Chinese yuan? So this is simply multiplication. So when I do 1 times 8, that's going to be 8. 0 times 8 is 0. 3 times 8 is 24. Write down the 4 and bring over the 2. 2 times 8 is 16, plus the 2 is 18. Write the 8 and bring over the 1. 7 times 8 is 56, plus the 1 is 57. Okay? Now next, I'll use a 0 placeholder and do 7 times 1. That's 7. 7 times 0 is 7. 3 times 7 is 21. Write down the 1, bring over the 2. 2 times 7 is 14, plus 2 is 16. Write the 6, carry the 1. 7 times 7 is 49, plus that 1 would be 50. And then add your partial products. There'll be 8, 7, 4, 9, 3, 6, and 5. Now, we count how many decimal places how many numbers are there to the right of the decimal point for each of the two numbers. In this case, there are 3 numbers behind the decimal point. Our answer will have 3 numbers behind the decimal point. So that decimal point is going to be between the 9 and the 4. Now it does say round to the nearest hundred. So here the 7 is in the hundredths place. Next to it is an 8. So we're going to round this off to 5639.4. We'll increase the 7 to an 8. So to answer that question, the value in Chinese yuan would be 5,639.48. Now, problem number 3. The water in a tank weighs 712.5 pounds. 1 cubic foot weighs 62.5 pounds. How many cubic feet does the tank hold? All right, so we're converting from pounds to cubic feet. We have to do a little division here because we know 1 cubic foot weighs 62.5 pounds, and the water in the tank is holding 712.5 pounds. So we want to find out how many cubic feet. So this is a division problem that we have set up here. Now in this case here, we're going to move the decimal point 1 place to the right because I want to make that divisor a whole number. Now if I move the decimal point 1 place to the right, I need to move the decimal point one place to the right here. So the decimal point will be behind the 5. Okay, now we can divide 625 into this number, 7125. Now we cannot divide 625 into 7. We cannot divide 625 into 71. We can divide 625 into 712. That's going to go one time. So 1 times 625 is 625. Subtract that from the 712, you're going to get, I think, 87. And then we bring down the 5. And then we divide 625 into 875. That's going to go one time, which is 625 here. Subtract 625 from 825, you're going to get 250. Now, what we need to do here is add a 0 behind the 5 and bring down that 0 here and divide 625 into 2500. That's going to go 4 times. And 4 times 625 is 2500 with a 0 remainder. So here, this tank can hold 11.4 cubic feet of water. All right, problem number 4, where we have a bank statement that shows a checking account with a balance of $74.42. The balance recorded in the checkbook shows only $29.65. After checking the canceled checks against the record of these checks, the customer finds that the bank has not yet recorded 6 checks in the amounts of $3.35, $9.64, $8.19, $7.64, $10.57, and $5.38. Is the bank record correct? Now, what I've already done here is added the amounts of the 6 canceled checks. As you can see here, that adds up to $44.77. Now, what I'm going to do here is add the $44.77 to the bank balance, to the balance that's in the checkbook of $29.65. And I'm going to find out, does that sum equal to the balance that's in the bank statement? And when we add that, you'll see that it does equal $74.42, which is the same as the bank statement. So here, the bank record is correct. All right, problem number 5 is to convert to decimal notation here. We got a number that's in scientific notation, which is 8.7 times 10 to the negative 6. Now, the exponent in our power of 10 is negative 6. That tells us how many places we need to move, either to the left or to the right. Since it's negative 6, we're going to take that 8.7 and move the decimal point 6 places. It's negative, so we got to go to the left 6 places. So it'll be 1, 2, 3, 4, 5, 6. Now, we only moving for 1, so that means we need to have 5 zeros in front of the 8 and the 7. So here, 0.00000 and then 87 is the decimal notation for 8.7 times 10 to the negative 6. All right, number 6. Write the numeral in the sentence in scientific notation. The distance between 2 planets is 24 billion meters. 24 billion meters. And we want to convert that into scientific notation. In this case here, we place a decimal point behind the very first non-zero digit. We have to place a decimal point behind the 2. So that's going to end up being 2.4 times 10 to some power. Now, if we place the decimal point behind the 2, let's count up how many digits are there behind that decimal point that we placed. That's 3, 6, 9, 10. That's going to be your exponent for 10. So in scientific notation, 24 billion meters in scientific notation will be 2.4 times 10 to the 10th meters. All right, number 7, write the numerals in the sentence in standard form. The distance from a planet to its sun is 8.7 times 10 to the 8th kilometers. Here, the exponent for the power of 10 is 8. That tells us we need to move the decimal point in 8.7, 8 places to the right. So here's 8.7. We need to move this decimal point 8 places, so that's to the right. And it's a positive 8, so we'll move it into the right. 1, 2, 3, 4, 5, 6, 7, 8. That means we need to add 7 zeros. Because we can only move it one place, so to make up for the remaining 7 places, we need to add 7 zeros behind it. So here, you have 8, 7, and then you'll have 7 zeros behind it, which will end up being 870 million kilometers for 8.7 times 10 to the 8th. Now, number 8, you're to multiply and write the result in scientific notation. Now, here we got 5.6 times 10 to the 3rd. 5 times 10 to the 3rd times 6 times 10 to the 3rd. In this case here, we're going to multiply these numbers here. 5 times 6, that's 30. And that's going to be 30 times 10. Now here we're going to add the exponents for 10, because we're multiplying powers of the same base. So 10 to the 3rd times 10 to the 3rd will be 10 to the 6th. Unfortunately, this number is not in scientific notation. For it to be scientific notation, this part has to be at least 1 but less than 10. Here, this is greater than 10. But we can write 30 in scientific notation as 3 times 10 to the 1. And then bring down the times 10 to the 6. And again, we'll add the exponents for 10, which will be 10 to the 7th. So in this case here, 3 times 10 to the 7th would be your answer in scientific notation. Okay? Because as you can see here, 30 is not in scientific notation. So if you place the decimal point behind the 3, that means there's one number behind it. So that's why it's 3 times 10 to the 1. Then multiply that by 10 to the 6. Add your exponents for 10. That'll give you the 10 to the 7th. So now you have 3 times 10 to the 7th. All right, number 9 is rounding. 155.523 to the nearest hundredth, and to the nearest tenth, to the nearest unit, to the nearest 10, and to the nearest hundred. In this case here, let's start with the nearest hundred, 155.523. The number in the hundredths place is a 2. The digit next to it is a 3. Here the 3 is less than 5, so the 2 will remain the same and all the digits behind it will be dropped off. So we'll write that as 155.52. And that's to the nearest hundred. Now to the nearest tenth, this time the number in the tens place is a 5. The digit to the right of that is a 2. Here the 2 is less than 5, so this 5 will remain the same, and all the other digits will drop off. So you'll have 155.5 for 155.523 rounded to the nearest tenth, 155.5. Now to the nearest unit or to the nearest whole number. Sometimes they say to the nearest whole number. You have to look at the number that's in the ones place. It's this 5 right here. to the digit to the right. The digit to the right of that is another 5. It's greater than or equal to 5. When it's 5 or bigger, you round that digit that you're rounding out to the next number. So 155 will go to 156. And we drop off the remaining numbers after the decimal point. Now we're going to take that same number and round to the nearest 10. This first 5 that's right after the 1 is a digit in the tens place. To the right of that is another 5. Here is 5 or bigger, so this 5 will increase to a 6. But this 5 will change to a 0. The numbers after the decimal point will drop off completely. So here it'll end up being 160. And you round to the nearest 100 in this case. 155, the 1 is in the hundreds place. Next to it is a 5. Is 5 or greater, so this 1 will increase to a 2. These two 5s will change to zeros, and the numbers after the decimal point drop out completely. So 155.523 rounded to the nearest 100 would be 200. And finally, number 10, the heaviest apple on record weighed 5.0451 pounds. The heaviest lemon weighed 11.481 pounds. How much heavier was the lemon than the apple? That's pretty much a simple subtraction problem. Because here we're going to do 11.481 minus 5.0451. And notice that I lined the decimal point up. And I'm going to go ahead and put a 0 here because I want to have the same number of decimal places for both of these. Now we can't subtract 1 from 0, so we have to do a little regrouping. And then do 10 minus 1, that's going to give you 9. We can't subtract 5 from 0, so we'll regroup again. Make that 7, this becomes 10. 10 minus 5 is 5. 7 minus 4 is 3. 4 minus 0 is 4. 11 minus 5 is 6. So here, the lemon was 6.4359 pounds heavier than the apple. Okay, now that was just a simple subtraction problem. Okay, that should be enough to assist you with some of the homework problems that are on the MyMathLab for Section 7.2.